if you are given a unit circle, you can determine the value of sine theta, cosine theta, and tangent theta just by looking at the coordinates of this point. A unit circle is a circle with a radius of 1 unit. Sine theta is equal to y coordinate of this point, which is here, y coordinate. Cosine theta is equal to x coordinate of this point, which is here. And tangent theta is equal to y coordinate over x coordinate. So which means sine theta over cosine theta, right? Okay, let me explain to you why that is like this. Now, this is theta. If the point, the coordinate of the point here is mn, this means that here is m unit, right? And this is n unit. I hope that you still remember this Dwakasol, which you learned in Form 3. Tangent is equal to opposite side divided by adjacent side. Cosine is equal to adjacent side divided by hypotenuse. And sine is equal to opposite side divided by hypotenuse. Now let me show you sine first. Sine theta. So this theta, SOH. Opposite side divided by the hypotenuse, which is 1. What is n? N is actually the y coordinate, right? Y coordinate. From here we can make a conclusion that if this is a unit circle, the question asks us what is the value of sine theta. We don't have to calculate, we just take the y coordinate of this point. Okay, so how about cosine theta? Let me show you over here. Cosine theta, CAH, adjacent side over hypotenuse. So adjacent side will be m, hypotenuse is 1, which means m, right? M is equal to x coordinate. Okay, now we know that cosine theta is equal to x coordinate. Okay, last one, tangent theta. Tangent theta is equal to DOA, opposite side divided by adjacent side. So opposite side will be here, and adjacent side will be m, right? So what is n? N is y coordinate, right? Y coordinate. And what's m? M is x coordinate. Okay, from here we also know that y coordinate is sine theta. X coordinate is cosine theta. Okay, remember this. Tangent theta is equal to sine theta over cosine theta. Okay, let me give you an example. Look at this one. Now here I have a unit circle. You will notice that the radius of this circle is equal to 1 unit. Now let's say if I ask you what is the value of sine 49 point, okay, I just round off this angle to 2 decimal places. What is the value of sine 49.94 degree? You don't have to calculate. You know that this is a unit circle. So if I ask you sine theta, sine this angle, you just take the y coordinate. Now let's take out our calculator and try to check. Sine 49.94 degree. You don't have to key in the degree sign, is okay, because your calculator have a D here, so your calculator know that this is in degree. Press equal. You notice that this is actually the y coordinate. So remember, sine theta, y coordinate. Okay, how about cosine theta? You don't have to calculate. You know it will be 0.6436 x coordinate. Now let's check using our calculator. Cosine 49.94 degree. This is our x coordinate. So how about tangent theta? Tangent theta is equal to y coordinate over x coordinate. Now let me use this one. Take the y coordinate divided by x coordinate first. 0.7653 over 0.7653. 6436. Okay, is equal to 1.1890. 1.1890. Okay, now let's take our calculator and try to press key in this angle. Tangent. Okay, let's remember this number first, 1.1891, or I can just store into our calculator. Press this one and then press A. Now this answer already stored in A. Now tangent 49.94. Okay, it's very close because this one already round off, so it's not exactly the same, but it's very close. Okay, so this one is actually can go many decimal places, and also I round off this one. That's why you do not get exactly the same value. Okay, so remember, sine theta is equal to y coordinate, cosine theta is equal to x coordinate, and tangent theta is equal to y coordinate divided by x coordinate, which is equal to sine theta over cosine theta. This method only can be used when you are given a unique circle. Means that the circle has a radius of 1 unit. So how about this if, now I give you another example. Let me okay, make it smaller. If I ask you, what is the value of sine 51.04? Can you say that sine 51.04 is equal to y coordinate, which is equal to 1.5551? Is it correct? Is this correct? No, this is not correct. Why? Because this is not a unique circle. The radius here is not equal to 1 unit. Therefore, you cannot use the method that I told you just now. So just now I told you that sine theta is equal to y coordinate, cosine theta is equal to x coordinate, and tangent theta is equal to y coordinate over x coordinate. That only can be applied when you are given a unique circle. Okay, this is not a unique circle, therefore you cannot say that, okay, sine of this angle is equal to this, cosine of this angle is equal to this. This is not correct, so be careful. Okay, the next thing that I want to share with you is this ASTC. When you are given an angle, first thing you need to know the angle lies in which quadrant. In the first quadrant, all positive, sine, cosine, tangent, all positive. In the second quadrant, only sine positive. In the third quadrant is tangent positive, and the last quadrant only cosine positive. Okay, why is that this? Sine theta is equal to y coordinate. You have to remember this one. Cosine theta x coordinate, and tangent theta is equal to y coordinate over x coordinate. Let me explain this way. Now, if you have an angle over here, sine theta, so we know that both of the coordinate will be positive, right? This is the first angle. This is first quadrant. First quadrant, second, this is first quadrant, remember, this is second quadrant, this is third quadrant, and the last one, this is fourth quadrant. Okay, so in the first quadrant, the x coordinate and y coordinate will be positive, right? Therefore, all will be positive. Sine theta, y coordinate positive, cosine theta, x coordinate positive, tangent theta, y coordinate over x coordinate, which will also give you positive value. So remember, in the first quadrant, all positive. So how about when we go to second quadrant? Why only sine positive, the rest will be negative? Now, this time is the angle go under the second quadrant. So the angle will be here. This is theta. Try to think the coordinate of this point. Here will be negative, right? Which is here. The x coordinate, negative, and y coordinate, which is here, positive. Okay, sine theta, y coordinate, positive, right? Cosine theta, x coordinate, negative. Tangent theta, y coordinate over x coordinate. Positive divided by negative, you will get a negative value. Therefore, in the second quadrant, only sine positive. So now, let's go to third quadrant. Now, let's say this time your angle go until the third quadrant, which is over here. So the data is here. Try to think the coordinate of this point, the sign of the coordinate. So the x coordinate will still be negative, and the y coordinate this time will be negative as well. This is x coordinate, and this is y coordinate of this point. So both are negative. Sine theta, negative. Cosine theta, negative. Tangent theta, y coordinate over x coordinate, negative divided by negative, you will get positive, right? Therefore, in this quadrant, tangent is positive. Now let's go to the last quadrant. Now you have another angle. This time the angle is in the fourth quadrant, which is a quadrant number 4, from here all the way here. Okay, theta. Try to think the sign of the coordinate of this point. So here will be positive, x coordinate, x coordinate will be here, and y coordinate will be here. Therefore, the x coordinate is positive, the y coordinate is negative. Now, sine theta, y coordinate, right, negative. Cosine theta, x coordinate, positive. Tangent theta, y coordinate over x coordinate, negative divided by positive, you will get a negative value, negative number. Okay, this is why in the last quadrant cosine is positive. So remember this, ASTC. So it's up to you, how do you want to remember this? Some students just remember ASTC, some students like to maybe remember this way, add sugar to coffee, and so on. You can use your own way as long as you can remember it. Okay, sine, cosine, and tangent actually you learn in modern math, right? This one you learn in modern math as well. But in in ACT math, we are going to learn 3 more trigonometric ratio, which is cosecant, secant, and cotangent. Okay, normally we do not write the full word for the cosecant, secant, and cotangent. For cosecant, we just write COSEC. This is the short form of cosecant. So for secant, we just write SEC. This is a short form of secant. And cotangent, we just write COT, which is short form for cotangent. Okay, so cosecant is equal to 1 over sine. Secant is equal to, okay, let me write over here. Cosecant is equal to 1 over sine. Secant is equal to 1 over cos. And last one, cotangent is equal to 1 over tangent. Okay, majority of the student will have no problem to remember this cotangent, because you see T, right? So cotangent 1 over tangent. Since the name also cotangent, so you know this is 1 over tangent. But for this one, cosecant and secant, some students will always get confused, mix up these two, cosecant and secant. So if you have this problem as well, you can think this way. Just look at the third letters. S 1 over sine, C 1 over cos, T 1 over tangent. So remember, cosecant is 1 over sine, secant is 1 over cos, and cotangent is 1 over tangent. So the sine, let's say if you have an angle, let me over here. Oh, let me use another one, thinner line. Okay, this one. Let's say you have an angle which is alpha. Okay, if I ask you, what is the value of sine alpha? Okay, since I know the angle, we don't have to determine. We cannot determine the value. I just ask you what the sign of the value. I mean positive or negative. Try to think sign. you remember ASTC, all sine, tangent, and cosine, right? But you do not, oh sorry, I don't want to, I want to talk about the cosecant. Okay, cosecant. For sine alpha, it should be no problem, right? According to the ASTC, you know in this quadrant sine is negative, right? So now let's talk about cosecant alpha. If alpha is in the third quadrant, is positive or negative? This is secant. This is cosecant. 1 over sine. So it will follow the sign of the sine. Do you get what I mean? Okay. So this is in this third quadrant, only tangent positive, right? So this is 1 over sine alpha. So sine alpha is negative, right? This is negative. In this third quadrant, this is negative. So we know that 1 over sine will be negative as well. Okay, so how about if I ask you the sine of cosecant, secant, and cotangent? They actually follow this ASTC. For cosecant, you just take cosecant is 1 over sine, right? So in the second quadrant, cosecant will be positive. First quadrant, cosecant will be positive as well. In the first quadrant, all will be positive. Okay, so secant is 1 over cos. So in the first quadrant, all positive, and in the second quadrant, secant will be negative. Tangent in the third quadrant, secant will be negative as well. In the fourth quadrant, secant is 1 over cos. So cos positive, secant will be positive as well. So the sign actually follow this one. If the cos is positive, then 1 over cos will be positive. If tangent is positive, then 1 over tangent will be positive. If sine is positive, then 1 over sine will be positive. Okay? In this quadrant, all positive. Okay, let me give you one more example. Let's say this time the angle is in the fourth quadrant. Okay, alpha. So secant alpha, cosecant alpha, and cotangent alpha. So we cannot determine the value of it because we don't know the size of it is alpha. I just want you to think about positive or negative. Now, secant is 1 over cos, right? So in this quadrant, cos will be positive, right? So 1 over cos will be positive as well. So how about this? Cosecant. Cosecant is 1 over sine. Sine is negative in this quadrant. So 1 over a negative number, then you will get negative. So what is cotangent? Cotangent is 1 over tangent. In this quadrant, only cosine positive, tangent is negative. So this is negative 1 over number 1 divided by a negative number, you will get negative as well. So this is the way how do we determine the sign of cosine, tangent, sine, cosecant, secant, and cotangent. So just remember ASTC. Add sugar to coffee, or some students just want to remember ASTC, or totally up to you, as long as you can remember it well. Okay, now let's try some questions. Based on the unit circle above, this is a unit circle. The radius of this circle is 1 unit. Determine the value of each of the following trigonometric function. Okay, so what do we need to remember is sine theta is equal to y coordinate, remember. Cosine theta is equal to x coordinate. Tangent theta is equal to y coordinate over x coordinate. Y coordinate over x coordinate. which is also equal to sine theta over cosine theta. Okay, so another one, ASTC, I hope that you remember. ASTC, all positive, only sine positive, this is tangent positive, and the last one is cosine positive. Okay, since this is a unique circle, we can determine the value of cosine, sine, and tangent really fast just by looking at the coordinate of the point. Now, let's look at ABC first. ABC here talking about alpha. So you forget about the theta and beta. Just look at this one. Okay, focus on this point. Cosine alpha, x coordinate. So the angle, the value will be, the answer will be 0.8241. Sine alpha, y coordinate, 0.5664. Tangent, y coordinate over x coordinate. Okay, take out your calculator and try to calculate 0.5664 divided by 0.8241. Okay, which is equal to 0.6879. 0.688. Oh, sorry, 6873. 73. Okay, I think this one should be no problem, right? Now let's go to theta. Theta is over here. This is theta. So we need to focus on this one. Sine theta, y coordinate. So will be 0.9432. Okay. Cosine theta, x coordinate, negative 0.3322. Tangent theta, y coordinate over x coordinate. Just press the calculator. Oh, sorry. 0.9432 divided by negative 0.3322. Okay, you should be able to get negative 2.8393. Now let's go to the last one, beta. So the angle beta is from here all the way to here, fourth quadrant. So alpha is first quadrant, theta second quadrant, and this beta fourth quadrant. Okay, cosine beta, cosine is x coordinate, which is equal to 0.5892. Sine beta, y coordinate, negative 0.8080. Tangent beta, y coordinate divided by x coordinate. So negative 0.8080 divided by 0.5892. Okay, you should be able to get this, negative 1.3714. Okay, now let's go back to this one. You will notice that alpha is the first quadrant, right? So sine, cosine, and tangent all positive, right? All positive, you see? All positive. Okay, so sine, this theta is in the second quadrant, only sine positive, the rest will be negative. Sine positive, the rest negative. Okay, now we go to the fourth quadrant, which is beta. According to the rules of ASTC, in this quadrant only cosine positive, right? You see, cosine positive, the rest negative. Okay, let's try one more question. Okay, try to recall back what we have learned just now. Sine theta is equal to y coordinate. Cosine theta is equal to x coordinate. Tangent theta is equal to y coordinate over x coordinate, which means tangent theta is equal to sine theta over cosine theta. Remember this one. And let's go back to this secant, cosecant, and cotangent. So the majority of the students will have no problem for cotangent because the name is cotangent, right? You see the tangent there. So we know that cotangent is equal to 1 over tangent. But these two, be careful, don't mix up these two. Still remember what I told just now, if you always mix up these two, just look at the third letters. So from here you know secant is 1 over cosine. Cosecant is 1 over sine. Okay, and don't forget the ASTC. In the first quadrant, all positive. In the second quadrant, only sign positive, which means cosecant will be positive as well, because cosecant is equal to 1 over sine, right? In the third quadrant, only tangent positive, which means cotangent will be positive as well, because cotangent is 1 over tangent. So in the fourth quadrant, only cosine positive, which means secant will be positive as well, 1 over cosine. Okay, now let's look at these questions. The diagram shows a unit circle. This is a circle with a radius of 1 unit. Determine the value of each of the following trigonometric functions in terms of n, or n. Okay, sine theta. Sine theta, y coordinate. So the answer will be n. Cosine theta, x coordinate, negative m. Tangent theta, y coordinate over x coordinate. So positive divided by negative, you get negative. The answer is in negative, so you will get negative n over m. So y coordinate over x coordinate. Okay, so before I show you this three, you can try to pause the video and do yourself, see whether you can get the answer correctly. Okay, secant, 1 over cos. So the answer will be, let me write this way first, 1 over cos. So it's 1 over x coordinate. So it will be negative 1 over m. So in your final answers, the negative, don't write the negative in front of the denominator, but write this way. Okay, how about this one? Cosecant theta, 1 over sine theta. Okay, so sine theta here is n, right? It means 1 over n. How about cotangent? Cotangent theta is equal to 1 over tangent theta. So 1 over tangent theta is equal to negative n over m. So it will become negative m over n. Okay, so this is the way how do we get the value of sine, cosine, tangent, secant, cosecant, and cotangent when we are given a unit circle. That's all for this video. See you next time. Thanks for watching. Bye bye.